So this is the last part of the homework from chapter 13 before we prep for our test. 13 through 18, these questions are all about finding the area of a triangle. Now, because these are not right triangles, the formula area equals 1/2 base times height is actually pretty complicated to try and discover. I mean, we would have to have, in this case, for instance, we would have to go through some trigonometry to figure out how tall the height of this is. Yeah, I could say 12.9 is the base, but I'm going to have to do some work to find the height here. And that can be said for all of these. This one, it has an exterior height, so we'd have to do some right triangle trigonometry to try to figure out that height, or we could try to figure out this height here. Sorry, it's not straight. But we would have to go in and make a bunch of calculations just to get that other measurement. What is the height of our triangle? Well, there were a lot of mathematicians that did a lot of work, and one of them was Heron. And Heron came up with a formula that was a workaround. It actually gave us the ability to find the area of a triangle without ever having to know any of the angles or what the perpendicular measurements are. See, none of these are perpendicular, and so it makes it hard to come up with a base and height. But he found a way around that. So we're going to talk about his method and formula that he discovered along the way. It's called Heron's formula, and it's an area formula. The area of any triangle is equal to the square root. This is not a formula you have to remember. I'll have all this written for the test. The square root of s times s minus a times s minus b times s minus c, where the sides of the triangle are a, b, and c. So you have a basic triangle. We'll see. And S is what's called the semi-perimeter, or half perimeter. Add A plus B plus C and divide by 2. That becomes our S in Heron's formula. So let's take a really simple example. We've got 7, 8, and 11 as our sides of our triangle. Well, the first thing we need to do is actually figure out what S equals. We're going to add all these up and divide by 2. 7 plus 11 is 18 plus 8 should come out 26. Divide that by 2, we get 13. So S would be 13. The area inside of this triangle here, okay, the area would equal the square root of 13 times. And here we just need 13 minus each of the different numbers. I don't really care which one's A and B. So 13 minus 11, 13 minus 7, and 13 minus 8. I can evaluate these one by one and do all that. I can also just throw the whole thing in the calculator. Just so we're kind of on the same path. 13 times 2 times that would be 6, and that would be 5. I can keep multiplying here and simplify this down to one number, or we can just jump right on to Desmos and put in the square root of, at this point we had 13 times 2 times 6 times 5, and we end up with 27.9. So the answer to our question was area 27.9 squared. If it's measured in meters, it's meters squared. Inches, inches squared. So please do put the unit on there and square it. That would be the correct way to do that. But that's it. If you know how to find the semi-perimeter and then just use Heron's formula, as was written down up here, you're good to go. It's a pretty straightforward one. Hopefully that won't take you too long to finish that assignment up. Good luck.